Now let us learn about another one of the interesting encodings, which is XOR encoding. So let me just quickly show you what the XOR gate means. So this is the gate, XOR gate. Do not get intimidated by the figure or something else, this mathematical equation. The concept is simple and clear. So whenever the A and B are same, the value, the truth table, so that means it is a collection of zeros and one. So whenever the value of A and B is same, either it can be 0 0 or it can be 1 1. So when the 0 0 happens or 1 1 happens, the output is 0 0. Otherwise, for other combination, like when A is 0, the alternate combination, when A is 0, B is 1. When A is 1, B is 0. The alternate combination, the output is 1. Remember that when both these inputs A and B are same, that is 0, otherwise it is 1. The concept is simple. Now whenever you do XOR, for example, let me just quickly grab a pen here and show you. So let us say I have 1, I have 0, the combination, let us say another 0 and 1. Let us say this is my first combination. Now this will be my key. Let us say this is my message. The message or key. So this is my message. The original message that needs to be encrypted, because this is the message. I cannot send this message as it is. Now I need to encrypt with something. So I'll do encryption now. Let us say I'll do some encryption using key. And this will be my key. Now let us say key is 1100. This is my key. Now I'll do encryption and I'll find that. So I'll do encryption using XOR. So the output will be from XOR. So what is 1 1? So whenever the value is same, 1 1, the value will be 0. Just here, this both value is 1 here. So when both value is 1, the output is 0. When 0 1, for the second one it is 1. And when 0 0 again it is 0. And for 1 and 0 it is 1. So this means this is our cipher text. This is encrypted text now. This is our cipher. Remember this. So this way it is encrypted. Now one of the interesting thing about this encryption is that, so whenever two things are given, we can calculate the third thing. That is important. So whenever message and key is known, we can calculate cipher. Whenever key and cipher is known, we can calculate message, actual message. And whenever maybe message and cipher is known, we can calculate key. So whenever two things are known, we can calculate the third thing. So that is important of XOR. So what does that mean? So whenever we know two things, let us say we know message and key, we can calculate the third thing, the third one. So that is the important thing over here. So let me close this. Now we have the challenge to solve. So just remember, whenever A and X is known, we can find B. Whenever B and X is known, we can calculate A. So we can calculate any third thing finding the two things. Because remember, B XOR of X is A. A of XOR of B is X. And B XOR of X is A. So that is always true. So that follows the transitive property. So that is a property of XOR. So that is the important thing. So let us grab this in the XOR. You can find this again in the resource section. I'll just grab it and I'll just paste in our input. Now look at this encoding. Do you think this encoding is what we have been learned so far? Because if you go at the top, if you go to the favorites, Is it base 64? No, because this does not end with equal sign. And if it was base 64, there is so many things here, this percentage and so on. It cannot be hex also, because hex is only a combination of numbers and alphabetical character from A to F. It cannot be obviously binary also, not octal, not decimal and anything. So this is not what we have learned so far. So that means it should be a encryption. It cannot be a data format. It should be inside the encryption. Now if I go to the encryption, is it the rotational, that is row 13 that we learned in the previous video? Doesn't seem to me, because if it was rotation, something should have been preserved, but this is clear a encryption. So that means I'll go to XOR and I'll just grab it over here in the XOR. Now you can see this is our plain message. This is our plain, or this is a ciphertext, not a plain message. This is a ciphertext. That means something that has been encoded by some key. Now we don't know what the key is. Is it 1? If I do 1, no, the output is different, but it is not a flag. If I do 2, it is also not the flag. You can see this is also some random text. I need to do this from 1 to 255 because there are 255 keys. So I need to check each and every key from 1 to 255. So that is not the good way. That is not the way to check, because we will take a lot of time here. So next thing to check is XOR brute force. If you want to search for all the keys, now I'll just put XOR brute force and it will have some sample length for you to check. The default value is 100, but you can always change this length. Now by the default 100, so it checked from key length from 1 to 100. Now for the key 1, we don't have the flag. Let us go till 29. You can see 30, 35. There is so many text, and still here is 4D is not our key. 53 is not our key. 56. See here at the 56, which is our key, because it gives us the flag. So that means 56 should be our key. Now let us remove this brute force and let us put our XOR, which is this one, and let us put in place of key 56. Now you'll see whenever 56 is given, we will have the flag. We'll have the flag over here. Now you can see we have found two things. We found the key and we have this ciphertext. Then we got the actual flag, actual message. So actual message is what we got from two things. So that means we need at least two things to find the third thing. Let us say that I need this ciphertext now. So for that I have to know this thing. So let me put it in our input. So whenever I put it here, then you can see ciphertext, the same text that we used earlier. See here, this one is same. This text is same as this one. So that means whenever two things are known, actual message and key, it will give us ciphertext, or ciphertext or key, it will give us actual message, or if you know actual message and this ciphertext, you will get keys. So either of them. So that is the importance of XOR, because it follows transitive property.